It's lonely out here. Cold and vast. There it is, our own island universe, containing over 200 billion stars and enough dust and gas to make billions more. 13 billion years in the making, our 100,000 light-year wide home galaxy now hosts some of the most beautiful and jaw-dropping structures humans have ever seen. The 7 wonders of the Milky Way Galaxy. Looking familiar? 7,000 light years away, these cosmic protrusions are composed of dust and gas, and are part of a larger region known as the Eagle Nebula, a fertile region of new star formation. The tallest pillar to the left of the image is roughly 4 light years high, while the protrusions seen at the top of the clouds that form the pillars are larger in size than the entire solar system. Evidence of radioactive explosion from a supernova in our developing solar system suggests that our sun formed alongside a cluster of other massive stars, like the cluster in the Eagle Nebula responsible for the pillars of creation. That's the only way the nebula from which the sun was born could have been exposed to a supernova that quickly, in the short period of time that represents, because supernova only come from massive stars, and those stars only live a few tens of millions of years. What that means is when you look at the environment of the Eagle Nebula or other star-forming regions, you're looking at exactly the kind of nascent environment that our sun formed in. Let me pierce through the gas and dust with you and show you what it's really like inside. Look at that radiation. A beautiful cosmic mess. In this ethereal view, the entire frame is peppered with bright stars, while baby stars are revealed being formed within the pillars themselves. The ghostly outlines of the pillars seem much more delicate and are silhouetted against an eerie blue haze. Without a doubt, one of the nearby wonders of our galaxy. Will we ever fully appreciate it as a species before they are gone? If the Milky Way had a downtown, a capital of stars, the Omega Centauri cluster would definitely fit the description. 15,800 light years from us, this stellar city is the largest ever found, sparkling with 10 million stars tightly packed within a region about 150 light years in diameter. If our sun were located in the middle of it, our night sky would be 1,600 times brighter, much brighter than even New York City skies. The stars in the core are so crowded that they are estimated to average only 0.1 light years away from each other. For comparison, our closest star, Proxima Centauri, is 4.2 light years away. This enigmatic 12 billion-year-old cluster exhibits the presence of different stellar populations with a spread of ages and chemical abundances. In fact, it may as well be the remnant core of a small galaxy merging with the Milky Way. Are we ever going to visit the Milky Way's starry jungle? Either way, stars can shine without darkness. When a star dies in a violent, fiery death, it spews its innards out across the sky, creating an expanding wave of gas and dust known as a supernova nebula. Arguably, the most famous of these supernova remnants is M1, also called the Crab Nebula. First observed by the Chinese nearly 1,000 years ago, the Crab Nebula is a masterpiece of destruction. According to records, the bright source was visible during the daytime for 23 days, shining 6 times as brightly as Venus. Lying approximately 6,300 light-years from Earth and stretching 10 light-years across, the material ejected from the Crab Nebula is moving at more than 3 million miles per hour, 4.8 million kilometers per hour. Powered by one of nature's most wondrous creations, a spinning neutron star. Roughly 20 kilometers, 12 miles in diameter, the pulsar rotates once every 33 milliseconds, or 30 times each second. The period of the pulsar's rotation is slowing by 38 nanoseconds per day due to the large amounts of energy carried away in the pulsar wind. Will we ever experience the light of a supernova explosion like our ancient civilization once did? With our current technology, what kind of impact will it have on our species and our relation to the cosmos? "1,300 light-years away from home, one of the most scrutinized and photographed objects in the night sky. The iconic Orion Nebula is the closest region of massive star formation to Earth. This 25 light-year wide nearby stellar show has revealed much about the process of how stars and planetary systems are formed from collapsing clouds of gas and dust. In fact, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of massive nearby stars in the nebula. See that? That's a solar system in the making. Each protoplanetary appears as a thick disk with a hole in the middle where the cool star is located. Radiation from nearby hot stars boils off material from the disk's surface. This material is then blown back into a comet-like tail by a stellar wind of radiation and subatomic particles streaming from the hot stars. Each picture, only 12.07 light days across. Each pixel, 50 astronomical units. That's right, human, 50 times the average distance from the Earth to the Sun. What type of planets, moons, and civilizations await? The next 3D flight video released by NASA just a few days ago will take you on a tour of the Orion Nebula. Beware of any children around you. This is classified as space porn. I'll be right back. Enjoy. Being able to fly through the nebula's tapestry in 3 dimensions gives people a much better sense of what the universe is really like. A uniquely immersive chance to see how new features appear as we shift the wavelengths of light normally invisible to our eyes. Science at its best. 26,000 light years from the solar system, and hidden from view by large clouds of cosmic dust in the spiral arms of the Milky Way Galaxy. Let me introduce you to our very own supermassive black hole, Sagittarius A. This tremendous black hole measures an estimated 44 million kilometers in diameter and has the mass of over 4 million suns. In a 16-year-long study using several of ESO's telescopes, a team of German astronomers has produced the most detailed view ever of the surroundings of the monster lurking at our galaxy's heart. By watching the motions of 28 stars orbiting the Milky Way's most central region with admirable patience, astronomers have been able to study and measure Sagittarius A with the ultimate precision. One particular star, known as S2, orbits the Milky Way center so fast that it completed one full revolution within the 16-year period of the study. That's no less than 5,000 kilometers a second. The galaxy is full of them. The smallest ones form when particular types of high-mass stars explode at the end of their lives. The Milky Way is home to about 100 million of these smaller black holes. We think some of those black holes are the seeds from which the much larger supermassive black holes grow to at least 1 million times more massive. That growth should happen in part by mergers with other black holes and in part by accretion of material from the part of the galaxy that surrounds the black hole. In the center of Sagittarius A is a gravitational singularity, a one-dimensional point which contains a huge mass in an infinitely small space, where density and gravity become infinite and space-time curves infinitely, where the laws of physics, as we know them, cease to operate. What awaits us beyond this universe? It once looked a lot like our sun, maybe providing light and warmth to other planets and moons. Now, 650 light years away, the iconic Helix Nebula is throwing a cosmic tantrum. When the hydrogen fuel for the fusion reaction runs out, the star will turn to helium for a fuel source, burning it into an even heavier mix of carbon, nitrogen, and oxygen. Eventually, the helium will also be exhausted, and the star dies, puffing off its outer gaseous layers, escaping into space, leaving only the incredibly dense white dwarf. A star whose lifespan may well exceed the current age of the universe. About 10,000 of these short-lived glowing objects are estimated to exist in the Milky Way alone. Let me use my infrared lens to pierce through the nebula. This view reveals distant stars and galaxies hiding behind the nebula. Filaments of material at the periphery are cooler strands of gas called cometary knots, each about as long as the solar system is wide. At the end of its lifetime, our sun will swell up into a red giant, expanding out beyond the orbit of Venus. Will we still be around to attend the sun's grand finale? Only about a dozen potentially habitable exoplanets have been detected so far. Astronomers say the universe should be teeming with alien worlds that could support life. The Milky Way alone may host at least 100 billion rocky planets, 60 billion such planets around faint red dwarf stars, which live up to twice the age of our sun. That's here. That's home. That's us. 99% of all life that has ever existed on Earth, more than 5 billion species, have gone extinct through a myriad of tumultuous events. But life finds a way. Now, with over 9 million species on it, 80% of the total count remains undiscovered. Our 4.5 billion year old home is an example of resilience, strength, and endurance. Cosmic radiation, supernova explosions, collisions with small galaxies, and asteroid impacts make much of the Milky Way too hellish for biology. Regardless of that, life here is everywhere, even where one would think conditions would be too much. The extreme heat of volcanoes, the bitter cold of the Arctic, the intense pressures, darkness, and lack of food found in the depths of the deepest oceans. Where did it all begin? Is life unique to Earth, or just one of countless places it calls home? We will see you in the next journey, and don't forget to like and subscribe. We are here. We are waiting.